This standard is about exponential equations. An exponential equation is an equation where the variable is in the exponent. There's a trick to solving these. We're going to need to get the base the same on both sides of the equation, and then we'll set the variables equal to each other. This first one, the bases are already the same. 2 to the x equals 2 to the 5th. You can kind of just look at that and see the only way that could be true would be if x equals 5. The second one, we have to think a little bit harder. 2 to the what equals 4? Well, I think you probably know 2 to the second equals 4, so x is 2. But there's another way we can think about this. We can rewrite 4 as 2 to the second. And now you start to see this idea. I have the same base on each side, a 2 and a 2. And in order for this to be true, x must equal 2. So we'll start making them a little bit harder. The same base in this case is going to be 3, because 3 to the second is 9. So I'll leave that one as 3 to the x plus 1. And on this side, I have 3 to the second. So since the bases are both the same, this equation will be true if the exponents are equal. So I'm going to set x plus 1 equal to 2. You can probably see the answer to that, but let's do algebra anyway. X equals 1. Same idea with this one, except we need to figure out a base that works for both 4 and 8. So 4 is 2 to the second, and 8 is 2 to the third. So I'm going to turn this side into 2 to the second. Put parentheses around that to make it really obvious that was the 4 raised to the 3x. And that equals 2 to the third, because that's 8, raised to the x minus 1. So when you have a power raised to a power, you multiply. So I'm going to multiply the 2 and the 3x. I'm going to multiply the 3 and the x minus 1, so I need to do the distributive property there. So 2 times 3x, that gives me 2 to the 6x. And on this side I have 2 to the 3x minus 3 with the distributive property. So in order for this to be true, the exponents have to equal each other. So I'm going to subtract 3x from each side. And I get 3x equals negative 3. So x equals negative 1. Last, we'll do one with a fraction in it. There's sort of a trick to this one. 1/2 you can think of as 1 over 2 to the 1, right? So I can move that into the numerator and make it 2 to the negative 1 equals, and 4 is 2 squared, so 2 to the second raised to the 2x plus 1. So I'll leave this side 2 to the negative 1. That equals 2 to the 4x plus 2. So I write negative 1 equals 4x plus 2. Subtract 2 from each side. Negative 3 equals 4x. Divide by 4.
Good night.
So x equals negative 3/4.